For thousands of years, humanity looked at the night sky and mistook slowness for stillness. The stars appeared permanent. The galaxy seemed frozen, and anything that changed between one night and the next could easily vanish before anyone noticed. Vera Rubin Observatory has now broken that illusion. Its first images revealed 10 million galaxies, an enormous river of stolen stars, an asteroid spinning faster than an object its size should survive, and evidence of a massive star that may have collapsed without producing an explosion. But Rubin's most revolutionary feature is not its camera. It is its memory. Every few nights, it photographs the sky again and asks one question: what changed while we were not looking? Vera Rubin Observatory does not observe the universe the way most telescopes do. Traditional observatories select a target, study it carefully, and move on. Rubin was designed to capture enormous areas of sky in a single exposure. Its camera repeatedly surveys the visible southern sky, creating a new record every few nights. Each image is then compared with everything the telescope has already seen. During its earliest observations, Rubin combined roughly 10 hours of data collected across only 7 nights. The result contained approximately 10 million galaxies. That number alone would be enough to define an extraordinary mission. But those galaxies represented only a tiny fraction of the observatory's expected 10-year survey. Rubin may eventually record around 20 billion galaxies, many of them photographed hundreds of times. This changes the purpose of an astronomical image. A single photograph shows where an object was. A sequence reveals what it is doing. A galaxy can brighten. A star can disappear. An asteroid can shift position. A distant explosion can rise and fade. Rubin is transforming the night sky into a film whose frames are separated by days rather than seconds. And hidden inside its first frames, astronomers found evidence of a cosmic event so large that it extended beyond the diameter of our own galaxy. Near the spiral galaxy Messier 61, Rubin revealed a faint stream of stars stretching approximately 163,000 light-years through space. The structure is longer than the Milky Way is wide. It was probably created when a smaller galaxy or a dense stellar system passed too close to Messier 61 and was slowly destroyed by gravity. Its stars were pulled away and stretched into an enormous trail, preserving the evidence of a collision that may have unfolded over hundreds of millions of years. The stream was not created recently. It had been hidden in the sky the entire time. Previous observatories could study individual sections of a region, but few combined Rubin's sensitivity with such a wide field of view. It was like examining scattered pieces of a footprint without ever stepping far enough back to see the complete track. Rubin saw the whole scar at once. This discovery suggests that many galaxies may be surrounded by similar structures, faint remains of smaller systems they absorbed during their growth. Over the next decade, Rubin could uncover thousands of these stellar streams, allowing astronomers to reconstruct the violent history of galaxies that appear peaceful today. Every river of displaced stars would reveal another act of cosmic destruction. But Rubin is not only uncovering ancient collisions, it is also discovering objects inside our own solar system that challenge what scientists thought solid matter could survive. The asteroid known as 2025 MN45 is approximately 710 meters wide, an object that large would normally require hours to complete a rotation. This asteroid does it in 1.88 minutes. Most asteroids of comparable size are believed to be rubble piles, collections of rocks and dust held together by weak gravity. If 2025 MN45 had that structure, its extraordinary rotation should tear it apart. Material near the surface would be thrown into space, and the asteroid would gradually disintegrate. Yet it remains intact. The most likely explanation is that the object is unusually dense and cohesive. It may be a fragment torn from the metallic or rocky interior of a larger planetary body destroyed during an ancient collision. That would mean Rubin has discovered a surviving piece of a lost world still spinning through the solar system billions of years after the body it belonged to disappeared. And this object was found during the observatory's early testing. In another short observational period, Rubin identified more than 11,000 previously unknown asteroids, including near-Earth objects and bodies orbiting beyond Neptune. The telescope may eventually discover around 1 million asteroids in its first full year of operation. Some will reveal how the planets formed and migrated. Others may provide advanced warning of small objects approaching Earth. Rubin is simultaneously studying the solar system's past and watching for what may enter our atmosphere next. But its most unsettling discoveries may involve objects that do not move or appear. They simply cease to exist. A massive star is supposed to announce its death. Its core collapses. The outer layers explode. And for a brief period, the resulting supernova can shine brighter than an entire galaxy. But some stars may skip the explosion completely. They collapse directly into black holes. No brilliant flash, no expanding cloud of debris. One moment the star exists, then it is gone. Astronomers call this a failed supernova, and finding one is extraordinarily difficult because the evidence is an absence. A possible candidate has been identified in the Andromeda Galaxy, where a massive star may have disappeared without producing the expected explosion. Rubin was built for exactly this kind of search.